Okay, tonight, connecting to and setting up a network. Most of you have already had Network Plus, right? Most of you have had the networking class. This hopefully will be some repeat of some of that stuff, although this is a little bit different approach to the way we do those things. Learn about TCP/IP protocols and standards Windows uses for networking. You got that. And they will ask you, as we know about some of the ports, some of the TCP ports. And I don't know, I guess they don't really ask the difference between TCP and UDP. That's more of a networking. But these are all just TCP, the major TCP ports. And if you'll do something clever like read the objectives, it'll probably even tell you which ports you need to know. You got a UDP question? Well,
I don't remember how it was worded.
Learn how to connect a computer to a network. Real tough, right? Unless you do things like we do. You had fun connecting your computer to the network, right?
Wasn't that the port security on that one's off? Bad Nick.
Bad Nick. Port security. Try sometime. Plug in your laptop on your desktop port, and then you won't be able to get anywhere, because from your Cisco days, you know about port security. Chris has to turn it back on, yep. And you have to pay him a fee. Just kidding. Huh? Got to pay the bills. Learn how to connect to a network. Learn how to configure and secure a multifunction router on a local network. Learn how to connect to the networks more in the network world, not the port security, but are you on the correct network? What's the default gateway? What's the subnet mask? Do all of those things match up correctly? So, client-server applications. And client-server is what we typically use. Client-server means that somebody logs onto something and gets something. The server serves up services. And when you start doing some of the security stuff, and we do some things like maybe put a Trojan on, you become the server because you're serving up, in the way you think about it, you're serving up your computer to the client who's going to be the guy that's hacking you. So we have client-server, 2 computers, 2 applications are involved. Communications at 3 levels, hardware, operating system, and application. This is a little bit, actually quite a bit different approach than is used in the OSI model. Depending on one computer addressing the other, one computer's got to connect to the other. You have to ask for something, and that's where the protocols come in. What protocol are we using? And they both have to be configured to use the same protocol, obviously, when we do this. And the Internet's where we're all going, right? When you get to be a network manager, your server could probably be down for about 3 days, but if you let the Internet go down for 32 seconds, and you'll know about it. I mean, really. The network's down. I used to get all the things, the network's down. Can you get to the server? Yeah. But I can't get to Facebook. I don't care if you can get to Facebook or not. Can you get to the resources that you need? So, what is networking? You guys network. Most of you network all the time because you got to get to Facebook, right? Networking, when we network, we share information. 2 types of things. Client-server means that something, and a lot of times say is superior to, is really not superior to. It can have more connections than something else. It's where you store information, where you store resources. And then we have peer-to-peer networking. Peer-to-peer is basically computer to computer, and you can share things that way also. So in this one, depending on the computer, we've got the web browser, the client software requests a web page from a web server, the server software, and the web server sends the requested data to the client. So we do those. When 2 devices communicate, they must use the same protocols, and you really do protocols language. Do you think about protocols as language? We had a president, and I don't remember which one, maybe Harrison, who they used to say he and his wife could have a very private conversation in a very public area. Because they spoke Chinese. And most people around them didn't. So, if we try to connect to a web server using an email protocol, is it going to work? Protocol to protocol, they have to match up. And even you go into those, the secure HTTP and HTTPS are not compatible. You have to have both of those. Sweet TCP/IP, and that is your networking plus stuff. Transmission control protocol, internet protocol, they typically go together. The other one, TCP, and then we have UDP. The difference is, and I digress, what's the difference in them? That old three-way handshake, right? Well, we send a SYN, and it sends back a SYN-ACK. Actually, it sends an ACK-SYN. We always say SYN-ACK because it just seems to go better that way. What the ACK does is acknowledges that synchronization. What do all these SYN packets do? What are they used for? They synchronize. That's true, but I know what that says. I know what SYN synchronize means. Says what it stands for. What does it do? What does it do? No, it doesn't. It initializes the numbering system. Because we're going to number these things, right? We're going to number all the packets so that you know what you got and what you didn't got, and that's the difference between TCP and UDP, is the acknowledgement. The reliable and unreliable, I don't like. Connection-oriented, connectionless sort of arrangement. Connection-oriented is like a telephone call. Hello. You dial the number, hello, this is, and then we have and then we acknowledge, and then we have the ACK where we acknowledge this SYN packet. So these two are kind of matched up. And each side establishes its own numbering system to keep track of the data packets that get sent back and forth.
If I remember, the denial of service is where it keeps them.
Denial of service, we'll digress here a second. There are a couple of ways to do denial of service. One is just overwhelm the system. It's kind of like if you wanted to overwhelm the interstate, how could you do that? Block it up, just send a bunch of trucks out there and tell them to drive slow, right? What's a good way to block up a network? Send a bunch of cars, send a bunch of traffic out there and send it slow. Problem is the networks have gotten so fast, that one's really difficult to do. Now, what he's talking about is called a SYN attack. And what we do when we're the hacker, we're not going to be the hacker. You send a SYN packet to the server, and it sends back the SYN-ACK, and you just don't do anything else. It's called a half-open connection. And when we get that half-open connection, eventually you fill up the buffers, which aren't very big. And once you fill up the buffers, which aren't very big, the web server can no longer contact, can no longer establish connections. Now, the way you as networkers are going to prevent that is you're going to configure your firewall correctly. So that the firewall will send that, you send the SYN-ACK, it'll send the ACK back to your server. And then if it doesn't get it from the other end, it'll eventually just drop that connection so that you're not filling up the buffers. The firewall's protecting you. All sorts of different ways to do that networking. And again, I know I think it's useful to talk about those things. We're regressing a little bit from the book kind of content here. It's broken into segments. Each segment's put into a packet, and we've done that. We have all these different layers of data. And what happens also after, one of the things that happens after this here, the SYN-ACK, during this process we're going to establish a window size. Not a Windows size, but a window size. How much data can we send at once? And when we talk about broken up into packets, when we break it up into packets of data, we can send more than one packet at a time. And I guess one of my analogies of that is if you had, let's say, a Maserati? How many people get in a Maserati? 2. Can go really fast though, right? Or what if I had a Greyhound bus? How many people can get in it? So we have a lot of data packets in the Greyhound bus, and we have 2 data packets in the Maserati.
Or 1 big pack.
Or what?
Or a fat check in 1.
It's still 2 packets, 2 data packets. So the more that we can get into this thing, the fewer times it has to be acknowledged, because TCP in the connection acknowledges receipt of all of the packets. If you send them, if you have a lot of data to send, which is going to be quicker. If you have a lot of kids to transport to the museum, what you going to use? You have 60 kids to transport to the museum, you're going to use the bus, right? Similar concept here. We'll put more data in a packet and send it. I also sometimes use a roller coaster for that too. You get into the things and you file in, you get into the cars and how many cars you got, how many different things that you can use. This is a different layers than you've seen in the past, isn't it? The ones you've seen in the past, the OSI, please do not throw sausage pizza away from the bottom up, or all people seem to need data processing from the top down. But this is the hardware level, the root level, wireless or network cables, kind of sort of similar to, when we talk about that, kind of sort of similar to layer 1, isn't it? Kind of sort of. Except that in the OSI model, the cables are really not part of layer 1. The voltages, the connectors, and all that stuff are part of the model, but not the cables themselves. Phone lines, so the root level of communication, wireless or network cables, and if you have wireless or wired, which is your preference?
Wired.
Wired, but all you guys have wireless phones, so you can give away all your information, right? Yeah. Much more convenient. So what we have is convenience versus security when we do these things. Phone lines, TV cables. Phone lines are actually very slow, but it's going to be the most secure. John's looking at me like, why? Where does the phone line go from to? It goes from me to you. Now, if I use TV cable lines, where does it go?
It's distributed.
I got this cable out here, and I got me connected, and you connected, and Robert connected, and AJ connected.
Not me, I use DirecTV.
And this is for internet, and Todd connected. So when you send your information, who has the possibility of seeing it?
Everybody.
Everybody that's connected. Everybody that's connected. Can you? Now they use some VLANs, some special kind of VLANs to keep people isolated on those things. Isolation VLANs to do those things. So in this thing includes the network adapter and the MAC address. Why is the MAC address important? We're doing hopefully a little bit of review. Yeah, it's unique. I agree. Well, so what?
Unless you have software that can clone your MAC.
So what? You can always clone your. You don't even have to need software. All you got to do is go to the properties of the NIC, and Windows will clone the MAC address for you. But what makes it significant? Identity. How does the data actually get delivered?
On the data line.
It gets delivered to your MAC address. That's what makes it special. Because if we didn't have unique MAC addresses, and I made a bunch of virtual machines in a Microsoft class one time, and we copied them and told it that we moved them. If you copy them, it will remake the MAC addresses. If you want to see something that's the most confusing networking thing that you will ever see in your life, have a bunch of machines out there that have the same MAC address.
Oh.
Sometimes it works and sometimes it doesn't work. And then finally do an ARP-A and say, hey, all these guys have the same MAC. So that didn't work out so well. But the MAC address, and it's a hexadecimal 48 48-bit hexadecimal number. The first half is the manufacturer, the second half is the serial number. Also known as a hardware address, or Cisco calls it what? BIA, burned in address. You may see it called that too. So in this thing, we do the browser to the web server, the TCP, and the operating. This is kind of the different things that they're talking about here. We have the browser is going to be the application we're talking about. The operating system does the IP addressing, the TCP IP, and then the hardware layer, Ethernet, the MAC address, the NIC sort of arrangement. And of course, in here, all of this stuff in this internet, we're going to have a lot of routers in there that have to be configured to use that. Operating system manages communication between itself and another. Computer using TCP uses IP addressing. We typically don't run into some problems that we did early on when there were not always standards in this TCP IP business. Back during the AOL days, and this goes way back to when we were using probably Windows 95, we used to have people that would come in and put the AOL IP stack in, which would immediately break their access. And they couldn't figure out why. IP is IP is IP. It is typically now, but it hasn't always been that case. The IP, the TCP IP, is called a stack because it's got a number of functions in it. Uses IP addressing, and IP addressing is we'll call it dotted quad, right? Dotted quad. Why is IP addressing significant? Something like that would be an IP address. It needs to be logical. And I'll just say some words, and all you guys that have had this say, oh, I hated that. But if we aggregate the addresses properly, then we don't have to have so many entries in the routers, for instance. The example in this building would be traffic coming from Virginia Beach. Our network in this room is, anybody know? Everybody knows, right? 10.60.211.0 network. We have a 10.60.61.0 network, a 10.60.64.0 network, a 10.60.208.0 network. The similarity here, this is actually supernetting.
okay.
Route aggregation, you'll hear called in Cisco. They all start with 10.60, which means that we can mask, and the subnet mask just tells the system how much of the address is network and how much of it is host. So at Virginia Beach, they just sent everything as 10.60 to Roanoke. Class B. Even though if we get into classes, that's really a Class A network, right? Should be, but depends on how you subnet it. But they send everything to Roanoke that's 10.60. When it gets to Roanoke, our router says, oh, we need to go to room 111. We need to go to wherever the 61, that's the faculty network, subnet. So we use more of the address to send it more specifically here. Organizing this stuff is a big deal.
And then it goes from there to devices.
And it goes from there to the individual machine, to the host address. The 0 is going to be the network address. It goes from there, and this is where we get into the MAC address. Once it gets into this room, how does it know who to go to? If Neil's watching his football game, how does it know where he is? His MAC address. And we have a protocol for that, right? What is that protocol? ARP. ARP matches up MAC addresses and IP addresses.
Isn't that what it's called? Address Resolution Protocol?
Yeah, Address Resolution Protocol.
Oh.
All right. You guys do remember some stuff, huh?
MAC tables and stuff.
MAC tables and stuff. Layer 2, the operating system IP address, 32-bit or 128-bit. The 32-bit IPv4, 128-bit IPv6, which has been imminent. We're going to imminently go to it in this country for about the last 6 or 7 years. There are tricks that we use with IPv4, NAT, private IP addresses, that make them go further, so that we haven't had to do that yet. Used to find computers on networks. Actually, IP addressing finds networks. MAC finds computers. Okay? Application layer, clients communicate with other on a port number. TCP, how many ports does TCP have? A lot! Like 65. The number, how can you guys ever forget that number? 65,000?
Oh, yeah.
536, right?
Yeah, that sounds right.
So each of these services, and over here on the board we have a number of them written down, a number of ports written down. Those services those numbers represent services, the default service. What if you wanted to use something that was really odd? Because if you go to Cox Cable and you want to set up a web server at your house, guess what? You can't, because port 80 is blocked. Oh, boo, huh? There is. What if you said your web server on port 8080? It's not blocked. How's somebody going to get there? They go to your MAC, your IP address, your public IP address, and if they go to port 80, is port 80 and port 8080 going to match up? You put a colon after the address and then specify the port number. If you just go to HTTP something, it's going to automatically go to 80. If we do HTTPS, it's going to go to 443. If we do POP3 is going to go to 110, and on and on and on and on, unless you specify something different. And if you look at a lot of these email providers, go look at how you would set up, for instance, most of them probably have Gmail accounts. What's the protocol number, what's the port number that they use? And they use something that's really not the standard, so that you have to configure your device to use that port number for that protocol.
Seems like everyone's like 663 or
Yeah, 660. Yeah, it's in the 600s, I remember. But they can use different ones, and what these numbers are says what port number that destination, that web server is listening on, to see if you're trying to connect to it. IP address is an example here. This is the colon, and what's port 25? SMTP, Mail Transfer Protocol. Yeah, and this one's going to port 80. If we actually put HTTP in front of it, would we have to specify port 80? But what if we wanted to go to port 8080? Then we would have to put HTTP and then 8080. Tell it what protocol to use and what port to use. The ports that they want you to know, that lots of tests want you to know, are the general ports for what we're going to do. And this is web server, email server, kind of a nice graphic here. HTTP is going to go by default to port 80, John. There she is. How do they get assigned? MAC we've talked about, it's embedded in the network adapter at the factory. Can you clone it? Yes. Are there softwares to clone it? Yes. Can you go into the properties of the NIC with Windows and change it? Yes. Why would you want to clone a MAC address? We'll talk some more security stuff. What if at your home, do you configure MAC addressing on your home router?
yeah, filtering.
MAC filter, you do?
Yep.
What if I just watched for a little while and got a MAC address and put that MAC address into my
It
NIC?
would work online. It's not
It would work.
fancy.
Yeah. That's one of the reasons you want to clone the MAC address, so that you look like something else. It could be to get into a network. It could be for other reasons. You can clone IP addresses too. The problem with cloning an IP address is the router don't know you cloned it, and it gets where it's going to send it, to that IP address.
I didn't know anything about that, so.
It's something that is okay for the casual person going by, but anybody that's really dedicated, and they're not going to be dedicated to hacking our home networks, but anybody that's dedicated to it is going to be able to find that information. Sign manually or by software the static IP address when we right-click properties, put in the IP address, the subnet mask, and the default gateway. Or we can get it automatically via the DHCP server. The DHCP server sends the IP address and other information, including the subnet mask, the default gateway, the DNS server, and maybe other services, addresses for other services that are available. DHCP, Dynamic Host Configuration Protocol, means that we get automatically, and in Windows now I think it says get automatic or something like that. Get an automatic IP address. IPv4, currently a shortage of IPv4 addresses. The shortage of IPv4 addresses is such that all of the IPv4 addresses that are available to the issuing company have been issued. There are no new addresses. Does that mean that all of the IP addresses in the world are being used? No. Microsoft just bought a company, and I've forgotten which one, and they bought the company just to get their IP addresses. I was doing a course, and this guy said that he was at another course, the instructor was at another course with somebody from, I think, the University of Iowa, said, oh, we've got a Class B network that we're not using. That's a lot of addresses. That's 32,000 addresses, isn't it? Something like that. So those things are available. 128-bit IPv6 works a little bit differently. You still have a subnet mask. It's kind of a pain to use because it's written in hexadecimal. Just try pinging an IPv6 address sometime. Just how long does it take you to write the address? So but 128-bit, and the numbers are staggering, the number of addresses that there are. I mean, and I can't recall any of them right now, but, well, one of them is, I said there's as many IP addresses as grains of sand on a beach.
Wow.
There's a lot. There's going to be a lot of IP demand. We already have a lot. I'm sorry?
INA, that's getting ready, that's not over there yet. Isn't that the one that our president was wanting to give control over?
Well, yeah, they want to give, yeah. IANA, the Internet, responsible for bookkeeping. I don't know exactly what they want to do with this UN thing, but everybody's got their own opinion. I got mine. In my opinion, how did the Internet come about anyway?
The military.
The military, ARPANET. No. It wasn't spied on the Russians.
Password.
Huh?
Password was password.
Password was password. It was the DARPA, the Defense Advanced Research Projects. And what it was designed for, and this goes way back, is an emergency communication system in the event of nuclear war. Yeah, because you lose all of the RF spectrum. It was designed as an emergency communications system. And now it's evolved into what it is. We paid for it. We built it. We bought it.
You didn't build that.
We own it.
Tax dollars.
Use another quote.
I know where it's going with that one. Used, and we've talked about these. I'm not going to go into subnetting and the binary. If you want to do that, have fun with it. If you want to do that, on my YouTube channel is a playlist that has some subnetting in it. if you want to watch those. Whether they're good or not, I don't know. I can't stand to hear myself, so I usually don't go and listen to me. So in these things, and these are just, I guess they'll ask these. They will ask these on Network Plus, I guarantee you that. But the Class A networks, and these are, the networks are broken into classes A, B, C, D, and E. Class A is got the number of possibilities, and they're based on what's called the subnet mask. The subnet net mask is a number under the address that tells you how much of it's network.
There's a question on A+ that asked about how many networks on a Class B. I remember that.
How many networks on a Class B? So now we know.
IP addresses, yeah.
IP address is 65. A Class B network subnet mask is 255.255.0.0. True? How many bits is that for the mask? 16 and 16. What's 2 to the 16th? 2 to the 16th. That's that number that everybody knows, right? 65,536. You might as well commit that one to memory. It keeps coming back. It really does. 65,536. FAT16. How many address locations are in FAT16? 65,536. So they may have some of those. The Class A, the Class B, the first octet. And the first octet, the first number set, was a 1 to 126, and we have a special one here, 127, which is for troubleshooting. And we generally use a grand total of one address. The whole thing. And so we have now taken for 16 million addresses, total number address in each network, so 16 million addresses possible, and we use one. But it's there. The octets, 1 to 126, and this one goes, 128 to 191, 192 to 223, and then this would be a C. A D is 224 to what? What's the next one? 239, because 240 will be next, right? Does that sound right? You just keep adding 1 to the binary. 1 to 126, which would be 0, and then all ones. 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, and these are going to be A, B, C, D, and then the E, which is experimental. It's got 4 ones in it. This is Class D's multicasting, E is experimental. Yeah, we got to 239 and then 240 to 254. This graphic is how much of the address and the octets, the 192.168.1.1, how much of it is network based on the subnet mask. And this subnet mask, this would be a Class A, right? And this subnet mask would be 255.0.0.0. 255 is the network, and then zeros for the host. So anything that has a 1 under it, it's network address in the subnet mask. Anything that has a 0 in it is host. So this one's going to be 255.255.0.0, 255.255.255.0.0. So if this was, and this was the Class C, this was in that Class C, Class full thing, we have 255.255.255.0, then that much of its network and that much of its host. Yes?
Is it possible for there to be like 255.0.255.255?
No. No.
Once the zeros start.
No. Once you start writing ones, they got to be consecutive to you start writing zeros, and they got to be consecutive to the end. You can't split them up like that. They don't have to be 255, and that's when you get into subnetting. They can be different numbers of ones in there. But that's beyond, I think, beyond the scope of the A+. It's not beyond the scope of the Network Plus, although they don't really ask very complex subnetting questions there. They definitely do on the Cisco test, though, don't they? And they ask variable link subnet masks on those. You know all those things that you guys didn't want to learn? I got a video on that, too. A few IP addresses are reserved for special use. The all ones is called the broadcast, right? The all zeros is the currently assigned IP address. It's actually any IP address. And 127.0.0.1 is called a loopback address. Loopback, and it's the one that's for troubleshooting. One of the places, I'll digress again, that the loopback comes in handy is when you're working with Active Directory and you have to be able to find your own DNS server, and if the IP address ever changes, it's just for the DNS server, put 127.0.0.1, it'll always be this computer regardless of what the actual IP address is. So you can use that one there. Subnets is when we break these networks into smaller networks. Subnetting, simplistically put, is if you had a $5 bill and you wanted to go buy a soda at a machine, it wouldn't take a $5 bill and there was no change machine, you'd ask somebody for 5 ones. You break the bigger into smaller pieces, and that's all you're really doing, and you do that with the ones. Say again? You can subnet the $5 into 5 ones, right? You can break the networks, the big networks, because how many 16 million addresses in the Class A? Is that realistic? What about the broadcast traffic? What about the broadcast traffic? 16 million, huh? Is it possible? Is it practical? ISPs usually maybe aggregate them at their site, but that would only be for routing purposes. Yeah. Have you ever looked at, how many of you have Cox cable? You ever looked at your subnet mask? Mine's 255.255.252.0.
You're on a small network.
Yeah. Smaller. Check it out.
I have a Shintel.
See what it is, just out of curiosity. Why do they do that? So that they can have more than Class C, more than the 254 addresses. So they put together, aggregate the networks that they want to then distribute in the area. If we beat the subnet mask, and you guys have all, except Tyler, I think, have had the subnet masking, and you'll get it. Don't worry. Subnet 69 to 256 subnets. Public IP addresses. We have a protocol here I talked about called NAT, which we translate. We have private protocols or private IP addresses and public IP addresses. Public IP addresses are routable on the internet. Private IP addresses are not. Anybody can use private IP addresses. You use a private IP address at home, right? 192.168 something probably. Yeah. You could use the 192.168 network. The zeros is the default. I would change it to something. You may want to change it to
That's how I log into my router.
You may want to change, yeah, because that's the default. And see, that's just one of those things. Yeah. Is somebody going to do it? Probably not, but it's just one of the things you want to change to make it a little more difficult. I use a 10 address on mine personally. 10 is the Class A private IP address. 172.16 is the Class B. You can use that, or 192.168. Anything in the 192.168 can be used. That whole subnet is dedicated to private IP addressing. And that's a lot of addresses if you think about it, because it's masked as a Class B network. But when we use them, we generally mask them as Class C networks with the 3 octets, with the 255s instead of the 2 octets with it. So the private IP addresses 10 to 172.16 through 172. You notice that in the B they didn't give us the whole thing. They gave us 16 to 31. 32 is the next network address that we use in those things. So if we have those, we're going to have a subnet in this one different than 255, right? 255 and then what? If we have 16, 4 be 192, 202, 224, 240, right? 255, 240.0.0. Yeah. Because we've got 16 hosts in here. Or actually well, it doesn't matter. We got 16 of each. Yeah. I think it's 240. IP addresses, IPv6, 128 bits. This is what one looks like. Yes, there are lots of addresses. And it will be once we learn how to manage it. It'll be easier to manage than IPv4. There is no NAT. Everybody loves that, right? Not networkers. You know why? Because everybody on your network now has a routable address, which means that somebody that wants to sit back and observe and construct your internal network topology can now do it. One of the things that NAT does is hides your internal network addressing structure, your internal topology. So yes and no. They are still changing things, and not as much as they were just a few years ago, but they still are making changes to it when they do these things. There is no NAT. The upside to it is it's a secure protocol. IPsec's built in. You don't have to port it like you do for IPv4. Link local. The link local wide area network, the link local is kind of the equivalent of the private IP address. The interface is nodes attachment, interface ID, neighbors. And these things will go out and find neighbors. And if you even look at your IPv6 on these machines, since Windows 7 by default installs IPv6, they'll go out and find the neighbors, which is kind of like NetBIOS, where we find that everybody that's on this network. Tunneling in 6 to 4, and tunneling is a way to transition from IPv4 to IPv6. If we, for instance, had IPv6 enabled on this network, but we needed to go through a bunch of IPv4 routers, we'd have to establish a 6 to 4 tunnel so that we could get IPv4 headers to get them to the other network would be stripped off and then be distributed using IPv6. So a number of transition protocols is really what they're calling these things. The unicast, multicast, and anycast address. Unicast goes to a single machine. Multicast goes to a group of machines. A broadcast goes to everybody on that network. An anycast is an IPv6 used by routers to identify multiple destinations, and packets are delivered to the closest destination. What this would allow you to do is something probably like what Google does. Do you think that all your Google requests go to Google in California? No. They go to the closest Google server. And that's what we're trying to do with this thing, get it to go to the closest resource that's available for that. Global cast, and I'm going to let you read this. They actually have changed some of this terminology. Not a lot, but a little bit of it. The global addressing, and this is how the advantage to IPv6 is you don't have to write the subnet mask. Remember in Cisco we did for what was considered we did like 24 or 64 or whatever, how many bits was in it, but you couldn't use that when you were configuring the routers. You can use that in IPv6, which is good. That means you don't have to write all those 128 bits for subnet masks. ipconfig, and if you haven't used ipconfig, take a look at the options that are available in it. It has a number of switches. ipconfig/all gives you some information. ipconfig display DNS, ipconfig flush DNS. If you want to see what websites are cached, that's the ipconfig /display DNS. If you have one that's wrong or messed up, you can flush it without restarting the machine. Host name, workgroup name, domain name. FQDN, the fully qualified domain name is basically the host name with a domain. Something.ecpi.edu would be a fully qualified domain name. www.microsoft.com is a fully qualified domain name. www represents some server there. And they use DNS, domain name resolution, in order to find those things. This, again, is their three-layer approach where we correlate the seven-layer OSI model. Do we actually generally use the seven-layer model? DoD model, TCP model is the one that is. The modeling here takes place, and like the network layer, this is modular. When we go from IPv4 to IPv6, the network layer is the only thing that you have to change. You don't have to change everything else in the system, and that makes it handy. We've talked about connection-oriented and the three-way handshake. I know I got ahead of myself. But connection-oriented means that we establish a connection before we start sending the data. And you will sometimes hear this called reliable, although I don't know what's actually unreliable about the other one. UDP, user datagram, is a connectionless protocol. And you generally hear connectionless, you just send in hope, right? Just hope it gets there. That's really not what happens. Something else is responsible for the acknowledgement. Like, instead of at TCP, instead of at layer 4, the responsibility may be the application at layer 7. For instance, if you use a TFTP server, it uses UDP. If it doesn't get there, UDP won't tell you that you didn't get the information. The server will tell you that it failed, that the transfer failed. These are in the objectives and in the book, and there's no real reason to go over those. Actually, I guess we can real quick. See how many parts you can get. HTTP. I know they're written over there. Don't look. HTTPS. 443. SMTP. 25. Okay, used to send email messages. POP and IMAP.
110, 143.
110 and 143.
DNS 53.
Is DNS up there?
No.
We'll get there. Telnet. Telnet. 23. By the way, that one's blocked by Cox too.
Cox blocking.
LDAP. 389. 3389 is remote desktop. SMB. That's one of the really low ones. I don't remember it either. FTP is 20 and 21. 21 and 20. FTP uses 2 ports. It uses 21 to establish a connection and then port 20 for the data connection. Secure shell. That's 22, isn't it?
Yeah.
It's not on that list. 22, is that somewhere? Is it? Oh, SSH, yeah, it is there.
Oh, all right.
Good guess, huh?
I was one off.
22. 21, what one off? If you're one off, then you're a whole different protocol. 21 was?
FTP.
And what was 23? So how could you have been one off?
I had a brainstorm.
Secure FTP, that's one that I really don't remember. It's one of the higher ones. SNMP, Simple Network Management Protocol.
That's 33.
Yeah, RDP is 3389. That's one that they actually may ask you. SNMP, I think this one, the SNMP, they may ask you the difference between SNMP 2 and 3. 3 is secure, 2 is not. Quick and easy, topics cover connecting. How tough is it to connect a machine using an Ethernet? Just plug it in.
Very safe.
As long as not very safe? Is that what you said? How can we make it safer?
Protocol. Port security.
Where we bind the port to a, hey, here comes that MAC address business again. And we actually have configured port security throughout I think every place. There are a few ports that don't have port security on them, but most of them. Which caused Chris, when he changed the machines in this room, he forgot about it, so he put the computers in and turned them in, and none of them would work. Because they were all on when they got plugged in, wrong MAC address, all the ports got shut down. You just gotta go back and reconfigure it. You can tell the switch to find automatically, to find the sticky switch on them. You can read those. Install the NIC, connect to the Ethernet cable, verify the lights. The lights are going to give you it's called a link light. You're going to probably get a link on the NIC and a link on the switch, or a light on the switch. Windows assumes DHCP. DHCP is the default if you want to put a static address in. You've got to go configure it. What happens if it assumes it's dynamic and you can't find a DHCP server? A PIPA. Very good. 169.254.something with a 255.255.0.0 and no gateway. So 169.254 means that it's trying to get an address from a DHCP server, but it can't get there. These are, you can do this. Red X indicates a problem. One of the things to check, and I'll pick on John because it happened to him the other day. He sat down and he said, no authentication server available, right?
Right.
Why would there not be? Everybody else got an authentication server. Why are you special?
Because
it's broken, and that's what your users are going to tell you. This works for everybody else. Oh, no, the system's messed up. This one probably was the cable. Got dislodged a little bit, whatever. Somebody actually tried to plug their laptop in and shut down the port, turned on port security. Any of those things could happen, but it's a layer 1 issue typically. If everybody else is working and you're not, then you may want to start looking at something in that area. Windows diagnostics. Change adapter settings. They're going to have activities for you to look at. And you guys mostly have already done this anyway, but right-click on it. We can change the properties of it. Select the following IP address. When you do on your virtual machines, after you configure all of that, Go ahead and set it back to dynamic. That way we won't get any address conflicts, I hope. Sometimes this DHCP server works on that machine doesn't do things as well as some of the others. And then they're going to have you do an alternate configuration. When we do these things, we can have a DHCP and an alternate, and it's set up so that what they say is if you bring your laptop from work to, or from home to work, and you have a DHCP server at work and don't have one at home, figure the odds, then you can set a static address in, and instead of getting the 169.254, you'll get your alternate IP address. Connect to a wired network. Lots of steps here to do there, right? Unsecured public hotspots or secured private hotspots. When you go to a public hotspot on Windows 7 and then Vista on up, you have the option of picking a work network, a home network, or a public network. If you're on a public hotspot, please pick public network. That does some different firewall configurations from the other two. The home network and the work network are essentially the same, except that you can't join one of the home networks, a home group on a work network. You can only join a home group on a home network. Wireless. I'm going to leave this for the wireless class. Generally, you're just going to go in and either type in a pre-shared key or an open system where you just tell it you want to go to this SSID and it goes there for you. There are other types of authentication protocols, 802.1x, one that you may want to learn about, which is a little more secure. Uses a radius server and maybe something like Active Directory to get your username and password to do that with. Security keys require SSID is not broadcasted. This is another one of those I ask about the MAC filtering. Yep, it may help. SSID not broadcasting. Yep, it might help. That SSID is sent regardless of whether you're broadcasting it or not. What you can do is send a machine that's already connected to something, a disassociation packet, and then when it reassociates, it has to send the SSID, and that's going to be in the packet. And then you use something like maybe a Wireshark in monitor mode on a Linux system to do those things. And the same thing with MAC filtering. You're going to be able to find those. I read a story, and no, I did not do this, of a guy that was in the airport. And airports used to charge you a whole bunch of money.
I've read that.
Whole bunch of money, right? He just sat down and was watching the traffic, and what he was looking for was the busiest MAC address. And then all of a sudden, that MAC address quit.
That's that fake access points. It says free American Airlines.
Yeah, so no, he just waited until that MAC address quit, and then he cloned that MAC address, and he was on the wireless. I'm not proposing that. It's illegal.
You can do that with the card that I have. He was talking about.
You can do. I mean, there's a bunch of softwares out there that you can get to clone the address.
Setting up a fake access point.
Yeah. Oh, you can do. You can set up fake access points with your phone. That's one of the ways to get into things, right? Wireless wide area network hardware, the SIM card, cellular, and you guys know more about this than could possibly be in the book. Connection. How many of you use your phones, or do you use your phone as an access point?
I have
They're pretty slow.
Sometimes. Yeah, it depends on where you are.
Does it?
Verizon's pretty fast.
Is it? AT&T won't let you do that unless you get permission, and then they're going to charge you more. Yeah, well, because they kind of overloaded themselves with all these, unlimited 10 gig, 30 gig, and on and on and on and on.
Data plans for a while there.
Yeah, I know. My son has one.
When the tethering first came out, it wasn't restricted.
Yeah.
People were just using that as their
Sure, is there...
primary internet server just browsing.
Yeah.
I mean, even playing a game online, if you already have it,
Uh-huh.
it doesn't draw very much internet at all. It's in the
Right.
case.
Yeah.
It's not even negative.
Yeah. So, tethering is something that there's some providers will allow it, some providers won't allow it unless you get permission to do it. Cellular network, dial-up connection.
What's that?
How many of you have used a dial-up connection lately?
Anytime you use
Okay, we'll just keep going, yeah.
anytime you use an ATM machine, it should go down.
Fax machine.
Yeah, a fax machine actually requires an analog connection. So if you're on a digital phone system, you have to get an adapter, a filter, yeah, to make your fax machine work because they do analog. You can read that. VPN connection, virtual private network. The data is encrypted. This is one that, I told my story too soon. If you're speaking Chinese in public, this would be what you were really doing. We've got the internet here, and we want to send a private connection across here. What we really do is just encrypt it at one end. Put a new IP address on it, because if we encrypt the IP address, the routers won't be able to read it. Put a header on it. Put an unencrypted header on it. Send it to the other end where it gets decrypted and sent to the correct location. So as we go across the internet, we have the encrypted connection.
That's good for the public hotspots, too. That's how they do all that pirating and stuff, right? VPNs?
Nah, not a whole lot. Now, there are VPN servers. There are some things that do that. There are, for instance, there are some, like watching U.S. TV. You can't generally do that on the internet in the U.S.
Shut down now.
There are some that are and some that aren't.
Just NT.
But what you can do is find a VPN server in Great Britain, maybe. And then it'll make your IP address appear to be someplace else.
My VPN has like 10 different countries.
10 different countries, yeah. What's the disadvantage here?
You gotta
Trust. Anytime you encrypt and decrypt, it takes resources and takes time.
Would logging on to watch DirecTV be considered a VPN?
No. Well, it may be, but it's probably not, because there's no real reason to encrypt the DirecTV TV show. Or watching on CBS, that's just a connection. A VPN is a virtually private network. When we talked about the phone system, and I said it was the most secure, it's a private network.
I mean,
It's not a virtual private network, it's a private
network.
network.
Wendy's or something, you're watching your DirecTV that way.
Still not going to be a VPN. No. If you're in a public hotspot, and that's what AJ was saying, if you connect to a VPN, it's going to make it more secure because you're going to have all your transmissions are going to be encrypted. So, but anytime you encrypt and decrypt, it's going to take CPU resources, and it's going to take time. It's like public proxies. Oh yeah, they'll hide you. You can get lots of obfuscation. Good word, right? You can hide using those things, but man, they're slow.
Yeah, they are.
How does that resemble like the Tor client?
The Tor client really is a proxying system.
Yeah, 'cause it just bounces.
Yeah, it bounces all a lot of places. But they have the Tor has their own network set up, and it appears to be a little faster than most of the other stuff. But it's a proxying system.
That was created by the Navy, wasn't it?
I don't know who created it.
In the Navy.
Creating a VPN connection, da-da-da-da-da-da. I'll get done here in a minute. When we come back, I will go through the steps to create a VPN, to create a VPN connection. It's really tough to make a VPN connection on a server. All you got to do is install it.
He's right. I just looked it up. Developed with the U.S. Navy for purpose of protecting government communications.
The multifunction routers in the SOHO small office, home office network. It can route, multifunction. Well, multifunction when we have wireless and wired.
Because mine's a modem router combination.
Yeah, that's what they're going to. They didn't have. That's something that's the modem built into it. Something that's relatively new. Yeah, it is, and that's what I think Cox has gone to the multi, gone to the Comcast. Well, you can buy them at Best Buy too. I mean, you can buy the combinations. But this one it's talking about, when we're talking about multifunction, it functions as a router and as a switch. It says in here somewhere, as a switch. It also is a translator, because if you think, for the price that you pay for these things, they're pretty sophisticated little pieces of equipment. They'll take a wireless signal and put it on a wired network. They'll take a wired signal and put it on a wireless network. They'll route. They actually are switches. And you get the switch isolation that you get from a managed switch. And it has a DHCP server in it, right? And the radios and all that other stuff for the wireless access point. So, and, oh yeah, I forgot about that. It has a firewall. And it has NAT. It automatically NATs, or actually PATs for you, right? Port address translation, because we don't use a one-to-one translation. The difference between NAT and PAT, this says NAT, but NAT is a one-to-one, private to public. So that if you had 8 computers on your home network and you really use NAT, you'd have to have 8 public IP addresses. We don't do that. We use one, and then each of them gets an IP address and a port number. It's really PAT, or port address translation, because we only have a single address. A little technical thing, but I have seen that type of question, and I don't remember which one, but it wasn't on A+, but on a cert test. And it can be an FTP server. It also generally can be a well, we do port redirects. It generally can be a DMZ also, so that you can have your own DMZ in the systems. Always follow the directions how to install it. Each of them is going to be different. I guess the real thing here, good thing, new thing here, is that they generally make you set up security now when you turn them on, which they didn't used to do. Change the router passwords, change the SSID, change the IP address. That's from Matt, because he said it was 192.168.0, right?
01.
01, golly, guess what it came with? Is it admin or admin blank?
Admin password.
Admin password. See, there are like 3 of them: admin and a blank, admin and password. Cisco is admin and Cisco. So you need to change that stuff. Static IP addresses, configure the firewall, disable the ports, quality of service, a number of things, port filtering to open or close certain ports. And this is what you guys all use for your torrents, right? I don't know what a torrent is. Torrents are not necessarily illegal.
No, I use them to download my Linux.
If you do Linux, yeah, if you go get Backtrack or Kali or things like that, it's a whole lot faster to get that.
Pretty sure what I
2 or 3 gig. Don't say that. 2 or 3 gig DVD. It comes in a torrent a lot faster. What port filtering or port redirection does, when it comes up to your public address, if it comes to this public address and we say it's 3389, it will redirect the remote desktop to the IP address that we tell it to on that port. So that port 3389 goes through the firewall to the private IP address. Huh? Xbox Live. Port triggering opens the port when a PC on the network initiates communication through another port, and then the DMZ is where we want to allow everybody to have access to a few things. These are all the same thing, IP addressing, port triggering, port forwarding. The protocols, then you can obviously look those up. 802.11a, 54 megabits per second, but they have this, don't they? They have this on the A+. They have several of them where you need to know the protocol and the speed.
That's where they have that drag and drop on.
They have a drag and drop. So you may want to take a look at this thing. And the N, you're going to see different numbers. They say 500, you see 600, you see on and on and on. And AC is gigabit when we do those. Set up a wireless MIMO. MIMO, I don't think they'll ask about. Multiple input, multiple. What makes N faster? Before we had a single radio, we had multiple radios, multiple inputs, and multiple outputs in the system, which is going to make it a little bit faster.
That's not the latest, though. There's a new one.
AC,
Yeah.
which is still pretty darn expensive. Not too bad. I don't know, $160, $170 for an access point.
That's a lot faster.
It's a lot faster. It's just like N. N has a theoretical really high speed, but when you go buy it, if you buy that theoretical really high speed, you're going to spend that theoretical a lot of money.
It's good if you stream a lot.
If you stream a lot, true. How fast is your internet connection? We'll go through some logic here. 25 megabits per second, right? 75.
Yeah.
Okay. What's the speed of an 802.11n wireless? The slow one is 300, 600. Is that faster than 25 or 75?
Yep.
So where's your choke point?
The wireless one.
Nuh-uh. The wireless is a lot faster than your internet connection. It's the ISP.
If you're streaming from a server in your house.
If you're streaming from a server in the house, I agree. And that's where this stuff comes in handy, is for your internal network, internal file transfers. It's going to be much faster. The other thing where this comes in handy is this MIMO, multiple input, multiple output, if you have more than one person watching that movie. Because one of the great ways to do a slow down, not an actual absolute denial of service attack, but if you really want to slow down a wireless, go watch a movie.
So Netflix slow it down.
Yeah, wireless. We're talking about wireless because wireless is essentially a hub.
Actually, Netflix sued some, or is they're going to sue Comcast somebody for slowing.
Yeah, they're doing all that stuff. There are lots of, but that's beyond the scope of this course. We're talking about the technical stuff here, right? The 802.11n, it says choices are 5 and 2.4. The high-end ones actually use both frequencies, and they use them simultaneously. You can buy them with only the 2.4 gig. I did that for whatever reason because I don't really do a lot of streaming to wireless in the house, or a lot of file, and the range is better. But the 5 gigahertz range, these are better because of the multiple input, multiple output, and the power that's allowed on them. 5 gigahertz is going to be a shorter range than a 2.4 gigahertz. The higher the frequency, the shorter the range. That's just a rule of RF transmission. The lower the frequency, the longer the range.
So technically it's best to choose the lowest channel?
Technically it's best to choose a channel that nobody else is on. And the only channels that you really should choose are 1, 6, and 11, right? Those are the only ones that don't have crossovers from the other channels. There are only really 3 true channels in the 2.4.
What happens if you get pump out 1,800 watts?
Then the FCC will come and arrest you.
Oh, you can't do that. You can do it.
One of the things we talk about, the BG networks, G is faster than B substantially, and the way it handles stuff is faster. if you, by chance, and today you probably won't have anybody, if somebody connects a B network to your G network, you just reverted to a B network for all the devices. So that's one with the mixed ones. This is a big deal down here, the 40 or 20 megahertz bandwidth. How much space do you get to put the signal in? And N will use, if it's available, 40 megahertz. If somebody else comes online, it'll come back down and compress it to the 20 megahertz. And there are a number of things. INSSIDER is a good monitor, and I think it actually works on, I think they have an Android app for it. They don't have an Apple app, but I think as in INSSIDER, I think has an Android app. It's pretty good. It will give you the bandwidth, the amount that you have, the 20 or 40 megahertz. Radio power level of the device affects it. The antenna type, how much passive gain does the antenna have, is going to affect your range. Security keys, we got that. WEP. Let's just cross that out of our language. No more WEP. WPA2 is the one that you really want to use. These are, we're going back to disable, filter, Wi-Fi protected stuff. There is, by the way, if you go look around, and AJ may already have, that's the way you hack WPA. It's through the WPS, the automated setup system.
Why did you send me here?
Because you look at this stuff. You thought I was never going to get there, didn't you, Todd? Network communication. We covered a lot of territory, and I maybe kind of glossed over. You're going to get a wireless class, at least one, and maybe more.
We'll learn how to hack.
We do not teach hacking. It's illegal. Hacking is illegal unless you hack your own equipment.
Security defense.
What you need to know in order to protect your network is what the other guy is using to try to compromise your network. And you need to monitor your own network. How many of you have ever done a scan of your own home to see if maybe you have a virus poking its head out of your network? How many of you restrict outgoing traffic on your network at home? Scan your own network every once in a while. Learn to use these tools. Nmap is a good scanner. Learn how to use it. Scan your own IP address. How do you get your public IP address? You be quiet. How do you get your public IP address? Huh? IP config will give you your, if you do IP config here, what's it going to tell you? 10.60.211. something. Well, that's a private address. One of the places that you can get that from really quickly is a website called What's My IP.
Oh, yeah.
What'sMyIP.com will tell you what your public IP address is.
It's like the Comcast. This is the IP that Comcast gives to you.
Yeah, well, you can also get it off your router too if you look at it. So the small office, home office routers, the wireless, I know I glossed over that, but that's basically follow the instructions is what all that was about. Questions? Ready to take a break? Okay, so I said that I would show you how to do a VPN connection. And it will really, time it, see if it takes me even 2 minutes. So we go to the computer connections, and we'll go to open the network and connection sharing, set up a new connection, and then we'll connect to a workplace VPN, and then we will create a new connection, and the VPN connection and the address that you're going to use is 10.60.66.253, and I'll call it demo. 10.60.66.253. The username that's authorized is called VPN. The password that's authorized is capital password 1, capital P password 1. And the domain is dynamic content.
What was the password again?
Capital P, password 1.
Like the red,
Double check.
I saw it.
It didn't like it. Because I spelled dynamic wrong. Oh, well. DYNAMICCONTENT. I'm connected. That's it.
2 minutes, 41 seconds.
Well, actually, I timed it. It's 1 minute, 18 seconds, 1 minute, 18,
1 minute, 18 seconds.
yeah.
Now, the other end, the server has to be configured to accept that connection, obviously. And the way you do that is when you install routing and remote access, you check on VPN and it installs the VPN server service. Pretty easy, huh? Let's see something here real quick.
I see some hidden folders.
See some hidden folders. What you see up here is this little exclamation point that says click to troubleshoot, and you see this big red X go into the internet. When you create a VPN like I just did, and you don't do something called split tunneling, all of the traffic that I create goes down the VPN. So I can't get to the internet unless I can get to the internet via that other machine. Well, I was going to try to do, but the browser didn't start. I guess the browser did start. I'm using too many resources, but it's not going to let me get the internet. So that's the downside there is, and if you really want to know how to do it, you want to do a VPN, there's a process called split tunneling that you can find a procedure for on the internet pretty easily. But that's how much effort there is to create a VPN connection. Questions? Lab time.